Okay, last time we talked about rational expressions, basically fractions, and simplifying rational expressions. So now we're going to do multiplying and dividing. But remember, rational expression is a fractional expression. So when you multiply fractions, you multiply straight across the numerator, straight across the denominator. But remember, we get a shortcut in multiplying fractions. Let's say, whoops, sorry, need a pen. Let's say we had 2/3 times 9/4. Remember, we can, anything that's the same on the top and bottom, it doesn't matter if it's in the same fraction or not. Remember, reducing fractions. We can say, oh, well, that'll divide out with that 4. Okay, and this 9 and that 3 will divide out. And then we can multiply straight across 1 times 3, 1 times 2. Okay, same thing as getting 18/12, but then we have to simplify when our number's bigger. Okay, particularly remember we're going to have expressions. So I definitely want to simplify in the problem. Make things smaller always before you make them larger. Okay, so multiplying fractions. If there's anything in common in numerator and denominator, and look, this 5/10, I can change that to 1/2, right? Well, now, here's a 2 and a 2. So, if I multiply straight across, everything's marked out here but a 1. Everything's marked out here but the 7. Right? Same thing with variables. Okay, I'm always going to look at the numerals first. So I notice that this 9 and this 3 will divide out. Okay, that'll leave a 3 up here and a 1 down here if you want. What I'm doing is 3 divided by 3 is 1, 9 divided by 3 is 3. Right? Or 9 divided by 3 is 3. Look, here's a p squared and a p. So one of these p's get to be marked out and just leave a 1 there. One of these q's get to be marked out and leave a 1 instead of a 2 down here. So if I go straight across the top, I have an 8 times p times 3. So 8 times 3 is 24 times p. And on the bottom, I have 1 times q. Okay, I'm always going to double check and make sure I didn't miss anything, but all I have on the bottom is a q, so the number doesn't matter, and there's a p on top. Okay, that's all there is to it. All right, so look at this one. Okay, what I have to remember is this is just a times right here, and this is a times between them and a times. So everything is, first step, I got to make sure before I can do this that everything is indeed just being multiplied. Then anything that's the same on the top and the bottom can divide out. Okay, so there's no factors of 3 or 2. That's a q and that's a p. So that was the only thing that was the same. 3 times q, p times 2. Usually we put the numbers first. It's not wrong to put p2, right? Because 2 times 3, 3 times 2, multiplication and addition or commutative. But typically we write the numeral first. Okay, same thing here, except notice everything's not being multiplied, right? A bunch of this stuff is being added. So, you're right, we're going to factor. All right, with the leading coefficient of a 1, I know it's going to factor like that. If it'll factor, I just need 2 numbers that multiply to give 10 and add to give 7. So 5 and 2. The denominator, it's not quadratic, so all I can do is factor out a 3. Okay, same thing for that numerator. I can factor out a 6. The denominator is quadratic, so it's going to factor as 2 binomials. All I need are the 2 numbers that multiply to give negative 15 and positive 2. So that's positive 5 and negative 3. Now, notice the difference. Up here I had x squared plus 7x. That was just a plus. Here I've got this times that, and then there's a times, and there's a times. Everything has a times between it, right? Everything has a times between it. So anything that's the same on the top and the bottom can divide out. And there, a 6 and a 3 have a common factor, so we can do numerals like we always. If I wanted to write this 3 times 2 and just mark the 3 out, I could, right? Now, everything on top except the 2 times x minus 1 has canceled, and on the bottom I have an x minus 3. No, 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 right? Don't do it. Plus or minus between there. Okay, when you divide fractions, remember, you write the first one the same, change it to multiplication, and use the reciprocal. Sometimes people say copy, dot, flip. And then basically, it's just like we were doing your multiply, right? But if we're dividing fractions, the first one stays the same, you change the sign to a multiplication, then you flip the second one, you use the reciprocal, and then you work the multiplication problem. You cannot start canceling until it's multiplication between them. Okay, so start nice and slow with just a couple of numbers. This is the same thing as 3/4 times 16/5. And now it's just like we were doing. That's all there is to dividing fractions, right? I see that the 4 and the 16 will simplify. So 3 times 4 is 12. 1 times 5 is 5. Okay, copy, dot, flip. So copy, dot, flip. Okay, now remember, fraction bars are like invisible parentheses because it's telling me that all of this is the denominator. All of this is the numerator. So I can't just cancel the 4 and the 3p. Nope, they got a plus sign between them. Can't cancel each one individually. But if the entire thing just has a multiply between it, then I can cancel the entire thing. Okay, the 9 and the 6 have a factor of 3. 9 divided by 3 is 3. 6 divided by 3 is 2. Here's 2 p's and here's 3 p's, so 2 of them get to cancel out and leave just 1. On top, I have a 3. On the bottom, I have a 2p. Okay. All right, it's a division, so I'll write the first one the same. I copy it. Change it to multiplication, which is a dot, and use the reciprocal, or flip it upside down. Copy, dot, flip. I'm going to switch colors, maybe make it a little more obvious, I hope. Okay, I see here's a 5 and a 10. Here's an a squared and an a, so 1a gets to go away. Here's a b, and here's 2 b's, so get rid of one of them. Oh, now the 2 and the 8 can divide out. Okay, so all that's left up here, there's still an a, and there's a 4. Down here, there's a 2 and a b. Oh, look, I could have simplified some more. So don't forget to keep checking, right? Keep checking. Make sure it's completely simplified. All right, same thing. It's a division. So copy. Dot. Flip. Okay. Anything that's the same can divide out, and I notice right away I've got an x plus 3 up here and an x plus 3 here. Okay, and here I've got an x squared, here's an x, so that one x and one of these x's can go away. Okay, here's a 4. Now notice this is just times, times, okay, and this is times. These things are not only multiply between them, and they're not exactly the same. Okay, so far on the top, I have a 4 and then times 4x squared minus 1. And on the bottom, we have 2x plus 1. And then there's a negative x. I'll move it to the front in just a minute. Okay. If I'm missing these parentheses, that's a different thing. That means they're hooked together with a minus. But this is multiplied. This times this, right? So be careful. Now, just like that last one, we're not finished. Look, I noticed that, hey, I've got an exponent of 2 in there. Let me see if I can factor that. Oh, yeah, it's the difference of squares. So that's 2x plus 1, 2x minus 1, right? And then on the bottom, I'm going to go ahead and turn that around to not confuse us. And now I have a 2x plus 1. So 4 times 2x minus 1 on the top and a negative x on the bottom. And these won't cancel because there's not a times between here. There's a minus, a plus or a minus. Okay, I'm dividing or multiplying, so I need everything to be factors. I need everything to be just multiplied together. So I'm going to factor this stuff. Okay, so I've got to rewrite this anyhow as a multiplication problem. So I'm going to go ahead and factor it as I have to rewrite it. Okay, I'm going to go over to the side and factor this, and then just for sake of room on here, I may erase the factoring. But remember, if my leading coefficient is not a 1, I can't just write my factors there. I've got to do that factoring by grouping. So I need two numbers that multiply to give 6 and add to give 7. That is 6 and 1. Now I can factor by grouping. Factor it. Those are m's. Factor a 2m out, and that leaves m plus 3. Okay, these, all they have in common is a 1, so that leaves m plus 3. So factor out the m plus 3, and that leaves 2m plus 1. Okay, so now I've factored that. M plus 3, 2m plus 1. The bottom is the difference of squares, so that factor is easy enough. M plus 3, m minus 3. Now dot and flip. Okay, so this will be the numerator. All I can do is factor out an m, and that leaves m minus 3. Now I got to go over to the side and factor this thing. I need two numbers that multiply to give 10, add to give 11. That's 10 and 1, right? So I'm going to rewrite the problem. 2m squared plus 10m plus 1m plus 5. Okay, I can factor out a 2m. That leaves m plus 5. Can only factor out a 1. That leaves m plus 5. Now I can factor out the m plus 5, and that leaves 2m plus 1. Okay, so that's what goes down here. Now notice, when and only when everything has a multiply between it, everything, anything that's the same on top and bottom can divide out. Let's use a different color for emphasis. Okay, there's a 2m plus 1, there's a 2m plus 1, there's a m minus 3, and m minus 3. The only thing left on top is an m. The only thing left on bottom is m plus 5. So even though, look what a nasty problem that looked like, but hey, it wasn't any harder than the others. But a little bit longer because we had a longer factoring method, but not harder, right? One more. Okay, one more. Okay, so here I can factor out an a. That leaves b minus a. The bottom is the difference of squares, so it's a minus 1, a plus 1. So you copy, dot. Now I'm going to flip. This is a perfect square trinomial, or I need two numbers that multiply to give 1 and add to give 2, 1 and 1. And the bottom is just a minus b. I'm going to put it in parentheses just to emphasize, that it's a unit. Anything that's the same on top and bottom can divide out. Let's see, there's an a plus 1, there's an a plus 1. Okay, look at these. This is a b and an a and a b. They're not exactly the same. So my thought is, are they opposites? Minus plus. Plus minus. They're opposites. That means I can automatically cancel them, and what's going to be left is a negative 1. All right, so on the top, I have a negative 1 times a, negative a, and an a plus 1. And on the bottom, I have an a minus 1. Nope, nope, nope. Right? This one isn't a factor. Okay? Okay. Good luck. Let me know if you have any questions.